Yeah. Good morning, students.
Good morning,
Let us
students.
please mute yourself, dear students. Okay, right. Raghun sir, Raghun sir. Yeah, let us solve some problems on the balancing of. Okay, let us solve problem related to balancing of several masses rotating in the same plane. Already last class we have discussed the balancing of rotating masses in three different cases. First case is balancing of single mass by a single plane. Second case is balancing of single mass with two different masses. And third case is balancing of several masses rotating in same plane. Already we have discussed the graphical method and analytical method. Now in this class we are going to solve the problem related to the balancing of several masses rotating in same plane. So for this, let us note down one problem here. So when you are solving a problem, please be ready with your protractors and scales, okay, so that you can get exact solution. Now let us go through the problem here. Let me read this problem. You can see here four masses M1, M2, M3, and M4 are 200 kg, 300 kg, 240 kg, and 260 kg respectively. The corresponding radius of rotation are 0.2 meter, 0.15 meter, 0.25 meter, and zero point 0.3 meter respectively. And the angle between successive masses are 45 degree, that is between mass 1 and mass 2 is 45, between mass 2 and mass 3 is 75, and between mass 3 and mass 4 is 135 degrees. Now your aim is to find the position and magnitude of the balance mass required if radius of rotation is 0.2 meter. Okay. So for this problem, first step is write the given data. Given M1 is equals to mass 200 kg, M2 equals to 300 kg, M3 equals to 240 kg, and M4 equals to 260 kg. And radius of rotation for mass 1, that is R1 is 0.2 meter, R2 is 0.15 meter, R3 is 0.25 meter, and R4 is zero point 0.3 meter. And the angle made by the masses. The first mass 200 kg makes an angle of 0 degrees. Second mass makes an angle of 45 degrees. And third mass is making an angle of 45 plus 75, that is 120 degrees. And fourth mass is making an angle of 45 plus 75 plus this 135 degrees. Okay, which is comes around 255 degrees. Now your aim is to find out the balancing mass, which has to be kept at radius of 0.2 meter. Okay, they have given the balancing mass. They have given the balancing mass radius. Now your aim is to find out the magnitude of the balancing mass. Okay, in this problem, your aim is to find out the magnitude of the balancing mass. R has given, and you are supposed to find out the m value. This is the unknown term. So how to solve this one? Now for this mass m, a centrifugal force Fc is being acted. That I call it as Fc1. Similarly, for this mass 2, second force is Fc2, and for this mass third one, centrifugal force is Fc3, and this fourth mass Fc4. Okay, I have drawn the configuration diagram. First mass m1 200 kg at radius of 0.2 meter, making an angle of 0 degrees. Next, second mass is 300 kg, making an angle of 45 degrees with respect to the first mass at radius of R2 0.15 meter. Okay. Next, third mass is 240 kg, making an angle of theta 3, that is 45, plus angle between these two masses is 75. Total angle is 135 degrees. That means this total angle you can see here. This is the, with respect to this total angle is theta 3, which is 120 degrees, and theta 4, that is 45 plus 75 plus 135. Angle is 255 degrees. The fourth mass is kept at an angle, and with respect to this plane, this total angle is theta 4. Okay, and magnitude of the mass is 260 kg. Radius of rotation is 0.3 meter. This generates a centrifugal force Fc4. Now your aim is to find out the balancing mass m, which is unknown value. You can see this I have kept the dotted line, which is an imaginary line. I am assuming somewhere else at radius of 0.2 meter, the balancing mass m has to be kept at an angle theta with respect to this horizontal line. This makes an angle theta. Okay. Now my M already R has given 0.2 meter position of the balancing mass radius. Now I am supposed to find out the magnitude of mass M and the angle made by this balancing mass. So since the magnitude of centrifugal force are proportional to the product of each mass and its radius, so whatever the force I am getting here, that is proportional to its M into R. Okay, force is proportional to mass into radius. Now M1 R1 is I am getting the centrifugal force one. Sir, Durgesh sir, FC1, M1 R1. Similarly, FC2 I am getting M2 R2. For FC3, M3 R3, and FC4, M4 and R4. M1 R1 I am getting 200 into 0.2 meter, that is 40 kg meter. M2 R2 300 into 0.15, that is 45 kg meter. M3 R3 240 into 0.25, 60 kg meter. And M4 R4 260 into 0.3, that is 78 kg meter. Okay, are, are you able to clear up to now? Okay, we get first centrifugal force is 40 kg meter, second one is 45 kg meter, third 60 kg meter, and fourth one is the 78 kg meter. Let me write here. First I am getting FC1 40 kg meter, FC2, FC3, and FC4 45, 60, 78. This is 45, this is 60, this is 78 kg meter, kg meter. I got all these values. Now resolve the forces along x-axis and resolve the forces along y-axis. Before resolving, note down the angle made by all these one. Okay, what are the angles? Theta 1 is 0 degrees, theta 2 45, theta 3 is 120, theta 4 is 255. Let me write here. Theta 1 0, theta 2 is 45, theta 3 is 120, theta 4 is 255 degrees. Let me explain how we are getting these values again. If you see here, the first mass makes an angle of 0 degrees. Okay, and they have given successive angles. The angle between two successive masses are 40. First mass is between first mass and second mass is, so first mass is 0. Between first and second mass, it makes an angle of 45 degrees. Between second and third mass, the angle is 75 degrees. Okay, now how to get this one? Theta 3, that is sum of 45 plus 75. How much it comes? This comes as the 120 degrees. Now between angle between mass 3 and 4. What is the angle made by the mass 3 and 4? You can see here they have already given. Between mass 3 and 4, the angle is 135 degrees. Okay, theta is 135. But what is theta 4? Already they have given. Already we got. Between 3 is 120 plus 135. How much I am getting here? This comes around 255 degrees. This is how we can get all the values. Any doubts up to here, dear students? Please respond, anyone. Hello.
No, sir.
Okay, now
No,
resolve
sir.
the,
No, sir.
okay, thank you. Now resolve the forces horizontally. And how to write this equation for horizontal forces? M1 R1 cos theta 1 plus M2 R2 cos theta 2 plus M3 R3 cos theta 3 plus M4 R4 cos theta 4. So I'm getting this is the product. 40 is the product of M1 R1. 45 is the product of M2 R2. 60 is the product of M3 R3. 78 is the product of M4 R4. M1 R1 I'm getting it as 40. Theta 1 is 0. M2 R2 is 45. And cos theta 2 is 45 degrees. M3 R3 is 60. What is theta 3? 45 plus 75, that is 120 degrees. Similarly, M4R4 is 78 cos 255. Give me this value, dear students, in terms of kg meter we'll get. Give me this value. Similarly, in the meanwhile, let us solve for the vertical forces. That is given as M1R1 sin theta 1 plus M2R2 sin theta 2, M3R3 sin theta 3 plus M4R4 sin theta 4. M1R1 I am getting it as 40 sin 0, 45 sin 45 plus 60 sin 120 plus 78 sin 255. Give me this value. Dear student, fast. What is sigma h I am getting? Anyone is solving? So this comes as 21.6. This color is not visible. This comes as 21.6 kg meter, and sigma v it is coming as 8.5 kg meter. The same solution we are going to solve with the graphical method also, and we are getting the same answers. Okay, I got find the resultant force here. Resultant force is your centrifugal force, which is nothing but product of m into r, which is given by the root over sum of all the horizontal forces square plus sum of all the vertical forces square. What is sigma h we are getting on solving? 21.6 kg meter, and vertical force I am getting it as 8.5. This is 0.5 under root. What is the answer we are getting on solving this? The student, can anyone give me this answer? Please. Hello. Respond anyone. Which comes around 23.
20,
23.2, sir.
Right, 23.2 kg meter. Already they have
1
given this
kg.
problem. Right. This balancing mass has to be kept at radius of 0.2 meter. You can see here. In the problem, they have mentioned where this balance mass has to locate at radius of 0.2 meter. You can see. Find the position. Wait 1 second. You can see here. Find the position and magnitude of the balance mass required if its radius of rotation is 0.2 meter. Okay. Now I know this R value. What is R value here? 0.2 meter. If R value is not given, in that case, straight away you can take the product M into R equals to 23.2. But R is given as 0.2 meter. That's why I'm writing 0.2 is equals to 23.2 kg meter. Now from this, what is the mass? 23.
116.
Right. So we'll get in terms of kgs. Okay, this comes around 116 kg. Means mass of 116 kg we need to keep at radius r is equals to 0.2 meter. Okay. Now at what angle we need to keep this one? How to solve this one for this? Go for tan theta, which is given by sigma v by sigma h. What is sigma v we are having? 8.5, and sigma h is 21.6. From this, theta is equals to tan inverse 8.5 by 21.6. Can anyone give the theta value? Yes, students.
21.4, sir.
Right, 21.4 degrees is the theta value. Now this theta is the angle made by the resultant from the horizontal mass of 200 kg. Let me explain again here. This theta is the angle made by the resultant from the horizontal mass of 200 kg. If you see here, with respect to this, where, uh, with respect to this mass, I'm getting the resulting mass theta. You can see here. With respect to this mass, I'm getting the resulting mass. What is this value? 21.4 kg. Okay, this theta I am getting it as 21.4 kg. So this is in first quadrant. If we add 180 plus 21.4, you are getting the same in the opposite side. In fourth quadrant we are getting. Okay, already we have discussed this. So theta is 21.4, or I can write theta is angle of resultant from horizontal mass of 200 kg. That is theta is equals to 21.4. Therefore, angle of balancing mass from horizontal mass 200 kg, that is theta is equals to 180 plus 21.4, which comes around 201.48. Now read the solutions here. Mass we are getting 116 kg at radius 0.2 meter at an angle of 201.48. Okay, this is your solution. Remember the same solution. This solution we have done by analytical method. This solved by analytical method. Okay, same problem. Let us solve with help of the graphical method. Graphical solution. Let us solve the same problem by graphical solution. Okay. So FC1 is M1R1, FC2 is M2R2, FC3 is M3R3, and FC4 is M4R4. What is the values I am getting? FC1, FC2, FC3, and FC4. If you come here, 40, 45, 60, and 78. 40, 45, 60, and 78. Is it right? Let me check one more. Right. Kg meters. So now let us see how the angles are given. So theta 1 is 0, theta 2 is 45. Again between 2 and 3, angle is 75. That is theta 3 is equals to 45 plus 70, 125. And theta 4 is equals to, between 3 and 4, what is the angle made? 125 plus 130, 155, I think it is. Much angle? 135 degrees.
Sir,
Just tell me.
theta 3 is 120, sir. 120.
45 plus 70, yeah, 75 it is given.
Right, sir.
One second, let me cross check. 75 it is. Okay, thank you. 70 plus 50, that is 120. Okay, we are getting these angles. Okay, now our aim is to draw the configuration diagram. From the configuration diagram, we are going to draw the force diagram. Okay, or force polygon we are going to see. Now let us see how to draw the configuration diagram. So first force is, first centrifugal force is 40 kg meter, located at an angle of 0 degrees. Okay, this 40 is the product of M1 into R1. So I am using different colors for all the masses. So the first mass, okay, this is the first mass, M1. What is M1 value? Can anyone answer? Let me take these values also. So M1 200, 300, 240, 260. 240, 200, 300. 200, 300, 240, and 260. Okay. 0.2, 0.15, 0.25. Into 0.15, 0.25, and 0.3 radius of rotations. 0.15. Okay, right. Okay, let me draw here. Hmm. The first mass is 200 kg. This is radius of rotation 0.2. This is 200 kg. For the centrifugal force, how much I am getting? 40 kg meter. This makes an angle of 0 degrees. Now, where the second mass is located? At an angle of 45 degrees. Okay. Let me use some different color for the second mass. From here, making an angle of 45 degrees, you draw a line. This is second mass. M2 is equals to 300 kg at radius of rotation R2 0.15. This is R1 M1. This generates a centrifugal force of FC2, which is equals to 45 kg meter. Now this angle is 45 degrees. Okay. Now let us see about the third mass. Where third mass is located? Magnitude of third mass is 240 kg at radius of rotation 0.25 meter. At what angle? Already they have given second angle. This angle is 45 degrees. Between second mass and third mass, what is the angle made? It is the 75 degrees. Okay. Between second and third mass. Means from here you draw a line making an angle of 75 degrees, or you add these two 45 plus 75. How much I am getting? 120. So now this shows 90 degrees. From here making an angle of 30 degrees. You draw a line like this. Now this angle, what is this angle? This is now 75. If you add these two 45 plus 70, this total angle comes as 120 degrees. Now this is the position of the mass 3, which is equals to 240 kg at radius R3 is 0.25 meter. This generates a centrifugal force of M3 into R3, that is 60 kg meter. This is 45 kg meter. This is 40 kg meter. Now similarly go for the fourth mass 260 kg at radius of rotation 0.3. Now between this third mass, between third mass and fourth mass, what is the angle? 135 degrees. Now with respect to this first mass, the total angle is 255 degrees. You got it? How they have given? Between mass 1 and 2, 45 degrees, 2 and 3, 75. Between 3 and 4, so this 135 degrees is the angle between third and fourth mass. So from here, you draw a line making an angle of 135 degrees. So if I see the total angle is 255, first quadrant 90, second quadrant 90, 180 degrees, third quadrant 90, 270. Means from this line gives the 270 degrees line. So from here you draw a line up to 15 degrees, you go inside. You got it? Now if you see this total, now this angle is 135 degrees. If you add 45 plus 75 plus 135, the total angle is 255 degrees. Got it? This is your fourth mass M4, that is 260 kg at radius of rotation R4 is 0.3 meter. Okay, this generates a centrifugal force FC4 of 78. Okay, now for this problem, these four are the unbalanced masses. These four masses are to be balanced with help of a one balancing mass. So I don't know where the balancing mass will come. Okay, but they have given radius of rotation R. So for that, what I am doing, randomly I'm keeping somewhere else here. I'm assuming this is my I'm showing this is my position of the balancing mass m at radius 0.2 meter. Now angle we need to measure with respect to this is the angle theta. You got it. This generates a resultant force of Fc here. So this total diagram we can call it as the configuration diagram. This is your configuration diagram. What I have drawn, this I called as a configuration diagram. Got it? Okay, 4 different masses. Let me use one different color for the fourth mass. This is my fourth mass. Okay. Now you can see all the 4 masses are 4 different colors, and this is your balancing mass. This M is your balancing mass. Now from this configuration diagram, we are going to draw the a force polygon. Okay. Let me go next slide. Okay. How to solve the force polygon? Now draw force polygon. Okay. Now if we see, I'm having FC1 is 40 kg meter, FC2 is 45 kg meter, FC3 is 60 kg meter, and FC4 is 78 kg meter. Take the suitable scale. Okay, I'm solving this by taking suitable scale. How to take the suitable scale? Okay, in terms of kg meter, I'm choosing 10 kg meter is equals to 1 centimeter I'm taking. Now this 40 kg meter will come how much? Can anyone answer? The students? Hello? Anyone there or not? Hello? Please respond.
Yes, sir.
Yeah,
Yes, sir.
this comes around 4 centimeter. This comes around 4.5 centimeter. This comes around 6 centimeter. This comes around 7.8 centimeter. Okay. Now first we need to draw the. So this is first polygon, first line. This is given by the line AB. This is given by the line BC. This is given by the line CD. This is given by the line DE. Okay. Draw a line AB of length 4 centimeters. What is the first FC first force making an angle? Theta 1 is 0 degrees. Second centrifugal force making an angle of 45 degrees. Third centrifugal force is making an angle of 120 degrees. And fourth one is 255 degrees. You got it? Okay. This you can keep as separate. This is the scale I am following. Taking a suitable scale. 10 kg meter is 1 centimeter. In that I am getting FC1 is 40 kg meter, which is equals to 4 centimeter. Now first step, draw a line. Is this red color is visible or can I change the color? Dear students? Yes? No response. Okay. Draw a line AB of length 4 centimeters, making an angle of 0 degrees. First step is draw a line AB of length 4 centimeters. The line AB is 4 centimeters, but this magnitude is 40 kg meter. Okay. Okay. Starting from this point A, B, the length is 4 centimeters. This makes an angle of, please mute yourself. Yes, hello. Next, second line. Just from here, locate the plus mark like this so that we know where. So this is first, second, third, and fourth quadrant. Where the second line is coming, B to C. What is the length of the BC line? 4.5 centimeters. At what an angle? 45 degrees. So from this point, you draw a line making an angle of 45 degrees. Okay. Now with respect to this line, this makes an angle of 45 degrees. Up to how much length you need to draw? 4.5 centimeters. Okay. Somewhere else it will end. Locate this as point C. Again, make this as a reference point like this. Okay. B to C. So this length is 4.5 centimeter and this length is 4 centimeter. Third force 6 centimeters. At what angle? 120 degrees. Now tell me where 120 degrees will come here from this. The student. Okay, in the second quadrant we are getting. The first quadrant is 90 degrees. In second quadrant we are getting 120. So from here you draw a line of just wait. I'll use a razor. You draw a line. Okay. Now this total angle with respect to this x-axis. What is this total angle it is showing? Now this total angle comes around 120 degrees up to point D. What is the length? 6 centimeters. Again, just look at a point like this. Now where the fourth one is coming? 7.8 centimeter at an angle of 255 degrees. So fourth quadrant here, sorry, third quadrant, 255 comes in the third quadrant. This coming somewhere else here. Up to how much length we need to draw? Up to E. Now D to E is 7.8 centimeter. What is the resultant? Resultant is always the closing side of the polygon. Okay. Resultant I am drawing with a different color. Join A and E. Okay, next step is join A and E. Measure this angle theta. Okay. Procedure I am writing here step by step. Procedure to draw force polygon. Okay, first step A. Draw a line AB of length 4 centimeter at an angle theta equals to 0 degrees. Second step. Okay. From point B, draw a line of length 4.5 centimeters. That is BC is equals to 4.5 centimeters at an angle theta equals to 45 degrees. Next, what is the third step? From C, draw a line of length 6 centimeters. Okay, that is CD is equals to 6 centimeter at an angle theta equals to 120 degrees. Okay, from D, draw a line of length 7.8 centimeters. That is D to E is 7.8 centimeter and angle theta is 255 degrees. Next step, join the gap between A and E. Measure the length A and E. How much we are getting this A and E? If you measure this length A and E, and already have solved this problem, I am getting This length A and E is 2.8 centimeters. Okay, already have solved this, and I am giving the length A and E is 2.8. Sorry, it comes around 2.3 centimeter. Okay, resultant force Fc is equals to m into r, which is equals to Ae, that is 2.3 centimeter. But we know 1 centimeter is 10 kg meter. But we know that 1 centimeter is equals to 10 kg meter. Therefore, Fc is equals to m into r, Ae equals to 2.3 into 10. How much it is coming? I am writing here 2.3 into 10. 1 centimeter is 10 kg meter. I am converting centimeters to the kg meters. How much answer I am getting here? Yes, student. Anyone answer this? So I am getting Fc is equals to m into r is equals to Ae is equals to 2.3 into 10. That is 23 kg meter. Okay. M into r is equals to 23 kg meter. M I don't know. R is 0.2, which is equals to 23 kg meter. From this, what is the mass I am getting? Can anyone give me this answer? Yes, student. Hello. Give me this answer. 23 by 0.115. 115. Okay. Similarly, if you measure this angle, how much we are getting? If you measure this angle, this comes around 22 degrees. Okay. If you measure this angle, this comes around 22 degrees. This is in the first quadrant. Or if you extend this, the same, it is coming in the fourth quadrant, third quadrant. Okay. Measure this angle theta. Okay. M, and by measuring angle made by resultant, we are getting theta is around 22 degrees. Okay. And mass is around 115 kg. And balancing radius of rotation is 0.2 meter. This is the resultant we are getting from the graphical solution. The same we will compare the resultant with respect to the analytical method. In analytical method, we are getting mass equals to 116 kg. Radius of rotation already is given. Angle theta is 201 or 21.4 degrees. Okay, the same solution I am getting from the graphical method also. So with this, I will wind up this problem. Still, anyone having any doubts? In this case, balancing of several masses rotating in same plane. Please respond, dear students. If you don't respond, I don't know what I am, whether you are getting or not. Okay. Please respond, anyone. Any doubts? Okay, if you don't have any no doubts, try to solve this problem. Okay. Afternoon again, I'm having the class. 5th hour, I think. Okay. In that class, you are supposed to give me the solution. So note down this problem.
Sir,
Yes, tell me.
sir, in the exam we have to do any one method, right?
Any one method. They may ask either graphical or analytical. If they don't ask anything, it is your choice. You got my point.
So they will particularly give the question, right?
If they mention solve by graphical method, definitely you have to do graphical. If they are not asking any method, means you can, it is your choice whether you can go by analytical method or by graphical method. It is up to you. Anyone you can do, no issues.
Okay, sir.
Okay, can you solve this problem, dear students? Yes, mute yourself. Hello, mute yourselves. Hello, mute yourselves. Someone has unmuted. Hello, Reba, mute చేయండి అబ్బా. Yes, mute yourself. Hello. Rebab, someone has made disturbance. Mute yourself. Rebab, your phone number mute చేయండి. Hello, mute yourself, someone. Idiots. చెప్తున్న బుద్ధి లేదు. Okay, try to solve this problem. Here we are having 4 masses m1, m2, m3 and m4 having radius of rotation 200 mm, 150 mm, 250 mm and 300 mm. And the masses m1, m2, m3 and m4 are 200 kg, 300, 240 and 260 kg. The angle between successive masses are 45, 75 and 135. Same angles I am giving. Find the magnitude and direction of the balance mass required if radius of rotation is 200 mm. Okay. Same problem only. Already this we have solved, I think.
Sir, solved, sir.
I am not sure. Solved, but some data is different. Angles are different, I think. Let me check.
Sir, same angle, sir. We have solved now.
We have solved. Okay,
Yes.
okay, right. Okay, the same problem let us do with different. Okay. Change the angles.
Okay, sir.
Okay, let us solve the same problem by doing the different angles. Okay, first this is 30 degrees. Take this as some, give me some different random angle. 60 degrees and give this angle as some say 150 degrees. Okay, change the angle. First angle is 30, second angle is 60 degrees, third angle is 150 degrees. Okay, so m1 r1 which gives us fc1. What is m1 we are getting? 200 kg. R1 is 200 mm, that is 0.2 meters, which comes, what is the value this one? 200.2, 40 kg meter. Similarly, m2 r2, second force. m2 is 300 kg and r2 is 0.15 meter. 300 into 0.15. How much it is coming? Same procedure, only numericals may change in the exam. You got it? fc3, that is 240 into 0.25, which comes around 60 kg meter. And next force is m4r4 fc4, that comes around 260 into 0.3 meter, that is 78 kg meter. Solve the problem analytical as well as the graphical. Now let us go solve this by analytical method. Okay. First, theta 1 is 0. Second angle between 1 and 2. Theta 2 is the angle between 1 and 2. How much it is coming? 30 degrees. Theta 3 is the angle between second and third mass. That comes as 30 plus 60. 90 degrees. Already I have given. Second angle is 60 degrees. Okay. Theta 3 I am getting. Now theta 4. This is the angle between mass 3 and 4. Okay. Mass 3 angle is 90 plus 150. How much I am getting here? 240 degrees. Okay. Theta 1 is 0. Theta 2 is 30. Theta 3 is 90. And theta 4 is 240 degrees. So for this, every time you try to draw a configuration diagram. Okay. Let me go for the configuration diagram. First mass making an angle of 0 degrees. Okay, this is mass m1 r1 making an angle of 0 degrees. Second mass, from here you draw a line This is for second mass, making an angle of 30 degrees, and this is R2. Okay, where is the third mass? Exactly 90 degrees. This is your third mass M3 at radius R3. Now between 1 and 2, 1 is 0, second is 30. Between 2 and 3, this angle is 60 degrees. But what is the total angle with respect to mass 1? 90 degrees. Okay, like that I am drawing. Third mass completed. Now fourth mass, 240 degrees. Where the 240 will come? 19, 19 and 270. Means from here 30 degrees inside. Got my point. 270 minus of 30. 240 comes here. Somewhere else here. Now this angle is 30 degrees. Or between these two angles, how much it is? 150 degrees. Means 30 plus 60 plus 150. Total angle is 240 degrees. This is the mass M4 at radius R4. Now we got all the position of the angles between 1 and 2, 30, 2 and 3, 60, 3 and 4, 150 degrees. This mass 1 gives the centrifugal force Fc1, mass 2 gives your centrifugal force Fc2, third mass gives your centrifugal force Fc3, and fourth mass gives your Fc4. Okay, this we called as the configuration diagram. Remember, this is your configuration diagram. So from this diagram only we are going to get the force polygons. Okay, where the first force is located at an angle 0, where the second force is located at an angle of 30 degrees, where the third force is located at an angle of 90 degrees, where the fourth force is located at an angle of 240 degrees. Now these four are the disturbance masses. These four disturbance masses are to be balanced with a one more mass. So I am, for example, I am choosing somewhere else here a dotted line. This is my balance mass M and R. This to be located at radius R and theta. This blue line I'm supposed to find out. Now to find balancing mass M, R is given 0.2 meter and theta equals to how much? Okay, this we try to solve by using the analytical method. Try to find out sum of all the horizontal forces and sum of all the vertical forces. M1 R1 I am getting it as 40 cos 0. Second one is 45. What is second angle? 30 degrees. Third one is 60 cos 90 and fourth one is 78 cos 240. Similarly, vertical also sin 0, 45 sin 30, 60 sin 90, 78 sin 240. Give me these values, dear students, fast.
Sir, horizontal value 39.97, sir.
39 point, let it be 40. Next,
Sir,
vertical,
vertical value 14.95.
let it be 15. I am rounding it off. Okay. Now let us
Okay.
go for the resultant force, which is equals to Fc, which is given by product of M into R root over sigma h square plus sigma v square, which comes around 40 square plus. Give me this answer. 40 square plus 15 square.
Sir, 42.72.
42.72 kg meter I am getting. So mass I don't know, but radius of rotation. So earlier problem I am asking to keep at 0.2 meters. So for a change, instead of 0.2, let me keep this radius of rotation at 0.4 meter. You got my point. Okay. Instead of 200 mm, I want to keep this as 400 mm. Just I am changing. Okay. Now I want to keep it as 0.4. How much answer I am getting here? Mass 42.72 by 0.4. Give me the answer.
106.8.
106.8. Suppose if it is 0.2, how much we are getting? 42.72 by 0.2. Please answer.
Sir, 213.72, sir.
You got the difference? If you increase the radius of rotation, the magnitude of balancing mass is decreasing. Or if you decrease the radius of rotation, the magnitude of balancing mass is increasing, like that. Okay. This is the amount of the mass I need to keep, 106.8 kg at radius of rotation 0.4 meter. Next, you are supposed to find out the at what angle you need to keep this one. Tan theta, sigma v by sigma h. What is sigma v? We got here 15. Sigma h is 40. 15 by 40. Tan theta equals to. Give me the angle here from this theta is equals to. Can anyone solve it fast?
20.5, sir.
How much?
20.5.
20.55, sir.
20.55 is the angle. So this is the angle made by the, there is a balancing mass with respect to the resultant force. You can see here, this theta is the angle of resultant from horizontal mass. Theta is the angle of resultant from horizontal mass of 200 kg. Now therefore, angle of balancing mass, how much it will come? Balancing mass from 200 kg, theta equals to 180 plus 20.5, that is around 200.55. So you can keep the balancing mass in first quadrant, or you can keep the balancing mass in third quadrant. You got it? Suppose if these are my quadrants, where the balancing mass has to keep with respect to this mass, somewhere else I am getting here, theta equals to 20.55. This portion also I can keep, or exactly opposite to this one. You got it? This is my balancing mass, or this angle theta, how much it will come? This total angle 180 plus theta, that is 200.55. Okay, this is one possibility, and this is the second possibility I can keep. Either in first quadrant I can keep, or in the third quadrant. This is balancing mass m, which is equals to 115 kg. Sorry, 106 kg. And r is equals to 0.4 meter. Theta equals to 200.55 degrees. This is the solution. So with this, I will wind up this kind of problems. Afternoon, I would like to solve the balancing of several masses rotating in several planes. So now I have solved the problem related to the balancing of several masses rotating in same plane. You can see here title also, balancing of several masses rotating in same plane. Only one plane only we have solved. Now the same problem, if the balancing of several masses rotating in several planes, how to solve this? Okay, that I would like to do on the afternoon. Thank you, dear students. You can leave the class now, join the next class. Any doubts as of now? Let me take the attendance. Don't you? Stop recording.